Before we move on to some examples in optics, let's see how we draw a ray diagram. There are three principal rays. The first one is a ray from a top of the object parallel to the center line, which is perpendicular to the lens or mirror. The second ray is a ray through the center of the lens or mirror, which will go through undeflected. And the third, which is often not needed because 2 points are generally enough to define a position, but nevertheless the third ray is sort of like a mirror image of the first, and it is a ray that goes through the principal focal point, which will exit parallel to the center line of the lens. Let me draw a diagram up here to show you what I mean. I'm drawing the diagram with lenses rather than mirrors, because mirrors are much more simple. Mirrors, we know that the angle of incidence equals the angle of reflection, and we can work out everything from there. So if we have an object here and a lens, we can draw our three principal rays. The first one, the second one, which is undeflected, and the third one, which is similar to the first, except it goes through focus and then parallel. Where these rays meet, on the other side of the lens, will be the image. Some definitions used in the ray model. Objects. We've talked about objects previously, but objects are things that actually exist in real life and are a source of light. We talked about that they can be either scattered light from an object such as a human being or a tree, or often in optics we use an arrow, or it can be an object that emits light, like a light globe. The image is what you see. This is the light on the back of your retina when you look at somebody, for instance. And there are two types of images. There is a real image, and this is images that actually have the light coming out of them. And the example I showed you on the previous slide is a real image. Or there's a virtual image. These are images that don't have any light coming out of them, but they look like they do. Mirrors form virtual images. This will be clear in a moment when we do an example with a mirror. And finally, it's worth defining magnification. Magnification is the ratio of the image size to the size of the object. Okay, now let's draw some ray diagrams and do an example with plane mirrors and images. So for flat mirrors, and this is another way of saying a plane mirror, we have theta in equals theta out, which you might remember as the angle of incidence equals the angle of reflection, and everything can be worked out from this point. So to find the image of an object, think about the fact that the object has got lots of point sources of light on it, and look where those rays appear to be coming from. So even though we've got an extended object here in an arrow, you can think about it as being made up of a whole lot of point sources very close together. We'll just look at the point source on the tip of the arrow for this example. So we have one light ray that's coming directly perpendicular to the mirror. Because angle of incidence equals angle of reflection, it's going to bounce directly back. We've got another ray here that will go down and bounce back here. Now if we trace these rays back, so over the other side of the mirror where they appear to be coming from, this is where our image appears to be. So it's a virtual image because the light rays are not actually coming from this point in space, it just appears to our eye like they are. Now a question on plane mirrors and images. So the question is, if your height is h, how big does a mirror need to be in terms of h to actually see yourself completely from head to toe? So does it need to be the same height as you, h, or 2h, or a half h? Let's see. So let's draw a diagram here and we'll put on some rays. So here is a person, the mirror, and let's draw some rays. We'll draw a ray from the top of their head, hits the mirror and bounces back into their eye. If we followed that ray back, that's where their head would appear to be. We can do the same thing for their foot. A ray from their foot could follow this path, bounce back off the mirror, following the angle of incidence equals the angle of reflection, and go back into the eye. Now all we have to do is measure the distance between these 2 points, because we've got one point on the very top of the head and one point on the very bottom of the foot. And it turns out, if we put in h here, this equals h on 2. So the answer is a half h. It's interesting to note here that it actually doesn't depend on how far away you are from the mirror. Try this at home. If you stand in front of the mirror and you can't see your shoes, for instance, walking back further away will not help. And this is just because of the geometry of the situation, because of the triangles that form the image.